So today we're going to take a look at 3 very easy rules on mastering significant figures. The first rule is non-zero integers are always significant. Let's take a look at what this means. This means numbers like 1, 21, 55, 84, and even 13,457,981. These are all non-zero integers. So coming back to 1 is a non-zero integer, so it is considered a significant figure. Significant figure of this 1 means that there is one significant figure. 21, both of these digits are significant, so there are 2 significant figures in this value. 55, similarly, 55, both of them are non-zero integers, so this has 2 significant figures. 84, 2 significant figures, and 13 million, this value has 2, 3, 4, 5, 6, 7, 8, a total of 8 significant figures. Now, there are 2 exceptions, and this is where Rule 2 and Rule 3 comes in. Rule 2 is that zeros are not significant unless they are in between 2 significant digits. So just now we looked at non-zero integers. We're going to take a look at when can 0 be considered significant. The first one is when they are in between 2 significant digits. This one, a 0 by itself is not significant, right? It is not in between 2 significant digits. 10 is not significant, that 0, because it's not between any 2 significant digits. So 10 only has a significant figure of 1. Similarly, 0.1, this 0 is also not significant because there's nothing in front of it so that it could be sandwiched in the middle. Now, 105. Number 105, we see the 0 is in between 1 and 5, both of which are significant digits because both of them are non-zero integers, like we just talked about with Rule 1. So because 0 is sandwiched in between them, then here we can say that this value, 105, has 3 significant digits, 3 significant figures. Here we see that these 2 zeros are in between, sandwiched between an 8 and a 3. And so these 2 become significant as well, and you have 4 significant figures in this value of 8,003. Looking at this one, this is also an example of where 0 is in between 2 significant digits of 3 and 4. So this makes this 0 significant, and we have a total of 1, 2, 3, 4, 5, 6 significant figures. And the last one we're going to look at is there are 4 zeros in here. Not all of them are going to be significant. We see that this last one is not significant because there's nothing to the right of it to sandwich it. This means that the one next to it is also not significant because if this one's not significant, then there's nothing sandwiching this one on the right-hand side. They only have a 4 on the left. So these 2 are not significant. Let's take a look at this 0. This 0 is stuck between 2 of these 4s, which are both significant, so this makes this 0 significant. This 0 is between these 2 4s, and so this one is also significant. So when we look at this value that's 4 million something, we have 1, 2, 3, 4, 5 significant figures in this value. Now, rule number 3. Zeros are not significant. This is the part 2 of Rule 2, which is also Rule 3. They are trailing zeros after decimals. This means that if you have trailing zeros after decimal points, they are significant. Any other 0 that's not sandwiched and not trailing zeros, they are not significant. Let's take a look at trailing zeros. Trailing zeros. For example, here, 1, the value 1 has 1 significant figure. The value of 10, as we see it just now, This 0 didn't count, right? Not significant, so we only have one significant figure. Notice the significant figures are on this side. 10.0. Now, when we talk about this in whether it be math or specifically in science, a lot of times when you measure, say, 10 grams of something, and you use a balance, an electronic balance, that is accurate to the tenths decimal, the tenths place, this tells us that this 0 is significant because this 0 is a trailing 0 that is after the decimal, right? So it meets this rule here, but also the fact that it gives us an accuracy. This 0 then is sandwiched between this one, which is now significant because it's a trailing 0 after the decimal, and this 1. So sandwiched between this 0 becomes significant as well, and so here you have 3 significant figures. Looking at this one, we know that the hundredths place is significant because it's a trailing 0, right? It gives us the accuracy of a value up till the hundredths. So this 0 is in between them. This makes this 0 significant because this one's sandwiched. Similarly, this one is also sandwiched, if you could think about it that way. So that makes these 4 digits all significant. So we have 4 significant figures in this value. On to the next one. This one. Notice how there's a 1 now replaced by that 0. This is a trailing 0 again after the decimal, right? And then you have a 0 stuck in between these 2 ones. So this makes it 4 significant figures. This one, we're adding more zeros. Now we're getting more and more accurate. Tenths, hundredths to the thousandths now. So thousandths place, this one is significant. The 1 is significant. The 3 zeros in between are all sandwiched in between them. And so this makes it 5 significant figures. And the last one, this one, let's take a look. This 0 must be significant because it's sandwiched between 2 significant digits. This 0 is not after a decimal, right? It is not a trailing 0. So this one doesn't actually count as a significant digit. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. And the last one we're going to look at is this one that ends with a 0. This 0 is after the decimal. It gives us an accuracy. This 0 isn't really needed, but because of accuracy, this trailing 0 becomes significant. Now this 0 is sandwiched between something that is a significant 0 and a significant digit of 2. So this 0 is significant. We know this 0 is already significant. So this gives us a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 significant figures. And there you go. 3 easy steps to figuring out how many significant figures are in each value.